Welcome back to Dynamics of Machinery class. Today's topic: partial balancing of coupled locomotive. You can observe that in our actual train system or in our railway, we can see that the wheels are coupled through a rod. That is called coupled rod. The benefit is that it has a good resistance against slipping of the wheel from the rail. So a coupling rod cranks are placed diametrically opposite to the adjacent main driving crank. That is, coupling rod is placed in such a way that which will be diametrically opposite to the adjacent main driving crank. Also, it revolves along with the crank pin, and it will be considered as a revolving mass, and hence it is completely balanced. Coupling locomotive, the mass balancing the reciprocating part is distributed uniformly among all the coupled wheels so as to reduce the hammer flow. Next, let us see a problem in the topic of coupled locomotive. The following, listen the question. The following data refer to a four-wheel coupled locomotive with two inside cylinder engine. Two inside cylinder engine and four coupled wheels are there. Pitch of the cylinder is 600 mm. Reciprocating mass per cylinder 285 kg. Revolving mass per cylinder is 255 kg. Distance between driving wheels 1.5 meter. Distance between coupling rod are 1.9 meter. Diameter of driving wheel is 1.9 meter. Revolving mass for each coupling rod crank is 130 kg. Engine crank radius is 300 mm. Coupling rod crank radius is 240 mm. Distance of center of balance mass in a plane of driving wheel from the axle center is 750 mm. Angle between the engine crank is 90 degree. Angle made by the coupling rod crank with adjacent engine crank is 180 or diametrically opposite. The balanced mass required for the reciprocating parts is equally divided between each pair of coupled wheels. Determine, first one, the magnitude and position of balancing mass required in leading and trailing wheels to balance 2 by 3rd of reciprocating and whole of revolving part. Second question, hammer blow and maximum variation in tractive effort when the locomotive speed is 80 km per hour. It's a big question. Let us do the solution. Here we have two inside cylinders and there is four wheels, that is two leading wheels and two trailing wheels are there. In the first case we will consider only the leading wheels and there will be a outermost layer is coupling rod. These are the plain diagram. That is, there will be a two inner cylinder which is apart from 0.6 meter. That is, in your question, the pitch of cylinder, that is the distance between the cylinder, is 0.6 meter. Revolving mass is 285 kilogram. Reciprocating mass is given. Distance between two coupling rod is given. The plane of two coupling rod is 1.9 meter. Distance between two driving or leading wheel is 1.5 meter, and also distance between two cylinder is 0.6 meter. So you can easily find out the distance between B and C. That will become 0.45. And also you can let us assume that all the radius are given in your question and the fraction of reciprocating masses to be balanced is 2.3 and M2 is 130 kilogram, or radius of the diameter of the wheel is 1.9 meter or 0.95 meter radius. And the space diagram, let C and D are two cylinders and which will be 90 meters apart, and the coupling rod, the first coupling rod adjacent to the crank will be diametrically opposite or 180 degrees. So the first coupling rod will be opposite to the cylinder C, that is A will be opposite to A will be opposite to the plane C. Similarly D will be opposite to F, and the masses are given, that is mass of the reciprocating parts per cylinder to be balanced, that is 2 by 3rd of 285 of reciprocating mass 190 kilogram. But listen here, there are four drive wheels are there and the reciprocating mass have to be divided equally between the driving wheels and trailing wheels. Therefore, 95 kilogram taken for each of driving wheels and another 25 for each of trailing wheels. Let us make the tabular column. That is, we have A, B, C, D, E, F, and B is the reference plane. C and D are the planes for your cylinders, and in the cylinder having a mass of 350 kilogram, we can find out here, that is the whole revolving mass or reciprocating mass per cylinder. We can find out that revolving mass of coupling rod of each cylinder is given in your question 130 kilogram. Whole of revolving mass plus reciprocating mass for the cylinder, that is MC and MD, we can find out 255 revolving mass plus 2 by 3rd of reciprocating mass, and the half we will take. 2 by 3rd of reciprocating mass is 190, and for the driving wheel we will take the half, that is 95. Total is 350 kilogram, and B is taken as a reference plane. So the table here will be 350 kilogram, and balancing mass MB and ME are unknown, and 130 kilogram for the coupling rod. And similarly, the radius for the coupling rod is 0.24 meter, and the radius for the cylinder is given that 0.3 meter, and the balancing masses are placed at a radius of 0.75 meter. Now we can take the tabular column for constructing your force diagram and couple diagram. As the previous case, just multiply m times r, you will get here, and here there will be two unknowns, so we cannot proceed to draw the force diagram. So we will consider first to draw our couple polygon, since there will be only one unknown, that is ME, and here the column of MB will be 0, because the distance between the reference plane to the plane B is 0, because plane B is assumed that your reference plane. So now we can draw your first couple polygon. So here OA is there, and you can draw -64 from here table. You can here the -64, 47.25, 110 or 1.125. Draw the couple polygon. So OA opposite to OA, because it is the sign is negative, and from A to D you can draw another vector 110.25, and take a convenient scale in your paper and draw AD, and AD is in the direction or parallel to the mass D or the plane D, and similarly you can draw CD, and CD is 47.25, which is again parallel to plane C, and the CF or F is equal to 53.04. This is the plane of your coupling rod, and it should be closed for the equilibrium condition. The closing side should be 1.125 ME, which is equal to 73.4, and the angle you can measure to 22.2. And similarly we can find out that ME is equal to 69.68 kilogram, and angle is 222.1 degree counterclockwise from the plane D or the horizontal. Similarly, you can draw the force polygon. Here we will start OA and AD and CD, EF, all and FE. After that, it should be closed for the equilibrium condition. So we will join OE and measure, that is 0.75 MA. So sorry, 0.75 MB is equal to 52.3. You can measure in your scale. You can draw it with a convenient scale. You can measure the angle. You will get 228.27 counterclockwise from the plane D. Similarly, you will get MB is equal to 69.7 kilogram. So first case is completed. That is the balancing mass for the driving wheel is completed. Similarly, we will do the next case, magnitude and position of balancing mass with a trailing wheel. The mass is to be balanced for each trailing wheel. So first one, revolving mass for coupling rod per cylinder MA and MF is 130 kilogram. As far as considered the previous case, it will be the same. As well as mass of reciprocating parts MC and MD, we will take only 95 kilogram, because the trailing wheel, there will not be any revolving mass attached to this trailing wheel. Listen here, only the part of reciprocating mass is converted or acting on the case of a trailing wheel. So your table will be updated with the new values. Let us take as MB dash and ME dash for the trailing wheel and of the plane B and the plane E, the same distance are there, but you can take here the table, the values are ME dash, MB dash, and fill according with the previous case, and proceed with your coupled polygon as first, and you will find out 1.125 ME dash is 29.B, ME dash you will get 26.5 kilogram, and the angle is measured is 320 degree. Similarly, you can draw your force polygon. After finding out the mass ME dash, you can substitute here. You will get the value here 52.3, and the unknown MB you can find out. Here the MB dash you will get MB dash you will get 26.66 at an angle of 129. Summarizing above two cases, it is also represent the magnitude and the position of balancing in the driving and trailing wheel. Let us take as the first driving wheel E. The mass is 69.7 kilogram at an angle of 42.1 degree to the horizontal, that is 180 plus 42. Actual case it is for 221.1 degree, but here it will be the 180 plus 42, the same angle will be here, and the trailing wheel is here, it will be 40 degree to the OD, or 320 26.5 for the trailing wheel E. The case E we can consider this will be the first position, and for the second position, second balancing mass, the driving wheel mass is 75 at an angle 48 to the horizontal, and here trailing wheel B dash is 26.6. This is the conclusion or summarization of the balancing mass. The second part of our question, we have to find out the hammer blow. Hammer blow calculation requires balance mass required for the reciprocating masses only. So we can take it as a, let us BB and BE is the balancing mass required. Take same plane as B as a reference plane, and BB or MBB balancing mass for B, and C and D are only the concept of reciprocating mass alone, and B is the mass of plane E. And similarly we can draw here only one unknown BE. Here we can draw a coupled polygon, and you will get the value BE is equal to 28.71, and which will be similar to your BB, and you got the value of balancing mass is 28.71, and already given data velocity of the wheel is 80 km per hour, and or 22.22 meter per second, and diameter of wheel is 1.9 meter or radius is 0.95. So you can find out omega is equal to V by R is equal to 23.39 radian per second. So hammer blow is equal to BB omega square. Capital BB is the balancing mass is given, it is found out 28.71, and the omega is 23.39, and the radius of balancing mass to be placed at 0.75 is given value. So you will get the hammer blow is 11.78 kilonewton. And also maximum tractive force, the equation you just by heart, plus or minus root 2 1 minus CMR omega square, and put all the value, you will get the value. But listen here the value is the reciprocating, all the reciprocating mass you have to take, and the value is 22.05. Thank you.